पीछे बैक 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 फिक्स करो बैक जाके. Now we will take the module 3 electrochemistry और इस सेशन में आपका स्वागत है. और इसमें हमने 9 पॉइंट्स बनाए हैं. उन 9 पॉइंट्स रिगार्डिंग पूरा मॉड्यूल 3 डिस्कस किया जाएगा. वो मॉड्यूल इस प्रकार है. मॉड्यूल 3, नेम ऑफ द मॉड्यूल इज इलेक्ट्रोकेमिस्ट्री and the syllabus of the electrochemistry is introduction, Daniel cell. Second point, EMF of electromotive cell. And third point, Nust equation. Fourth point, application of Nust equation. And fourth is thermodynamic function, delta H, delta F and delta S with respect to EMF. Fifth point is lead storage battery, and sixth point is corrosion, introduction of corrosion, types of corrosion and mechanism of corrosion. Seventh point is effect of corrosion and its prevention in different field for engineers. And eighth point is phase rule, that is introduction part, and last point, that is phase diagram of water system. So this is the module 3 electrochemistry, which will be discussed thoroughly one by one. In case of electrochemistry, we come to their discussion about diagram. Production of electricity from energy released during spontaneous chemical reaction. That is electrochemical cell or Daniel cell. This is the basic introduction about electrochemistry, which contain 2 electrode voltmeter, which contain the zinc electrode and copper electrode, and it will be the migrate from zinc sulfate in the form of electrolyte, and second contain the copper sulfate in the form of electrolyte. In case of the zinc sulfate, zinc will be dissociate. Zinc ion will be dissociate into zinc and providing 2 electron. This is occur in this solution, and this is the oxidation part. Similarly, in the reduction part, copper sulfate will be dissociate and copper will be taken 2 electron and convert into copper in the form of reduction. And this is the copper electrode, this is the zinc electrode, and this is the electron flow in this way and current flow in this way. Here U tube are also looked here, like U-like tube, which contain the salt bridge like K2SO4, and here SO4 is the common ion which are present in both electrolytes. Electrode potential equal to 1.1 volt, where concentration of zinc and copper is unity. If concentration of zinc and copper is unity, so electrode potential will be 1.1 volt. This device is called a galvanic or voltaic cell, and after dissociation there are 2 anode and cathode. Anode contain the oxidation reaction, cathode contain the reduction reaction. Here zinc convert into zinc ion after providing 2 electrons. This is the oxidation state at anode, and copper getting the 2 electron and convert into copper solid, that is reduction at cathode. The overall reaction is zinc plus copper ion convert into copper ion plus zinc. This is the cell reaction. So what is the purpose of the salt bridge? We can simply understand here, that is salt bridge. A salt bridge is a U-shaped tube containing concentrated solution of inert electrolyte like KCl, K2SO4, AgCl, etc. Now, the cell representation, we can simply observe that the left electrode convert into right electrode through electron flow. Here M ion concentration double line, M ion concentration single line metal. So this is the oxidation part, this is the reduction part, and double line indicate that this is a salt bridge. This oxidation part is the anodic part, that is negative pole, and this reduction cathode is positive pole, and this is the reduction part. So for example, we are taking that zinc converted to zinc ion, and it will be connected with salt bridge, copper ion and copper. So flow of electron from zinc to copper. So this is the basic representation of the cell. So EMF of the cell, this is the connecting points. So EMF of the electrochemical cell, it is a coupling of the two half cell. For example, Daniell cell, zinc single line zinc sulfate aqueous, double line copper sulfate aqueous, single line copper ion. So the cell electrochemical cell EMF of the cell is equal to E cell is equal to E right minus E left, where E cell is equal to EMF of the cell, E right is equal to reduction potential of the cathode, and E left is equal to reduction potential of anode. So E cell is equal to positive indicate the reaction of the feasible, reaction will be feasible, and if E cell will be negative, this cell value will be negative, so it indicates the reaction is non-feasible. So here we have taken one example. Write the EMF of the following cell reaction. So copper plus 2Ag plus convert into copper plus 2Ag solid. So half reaction will be cathode anodic reaction, and after putting this value we can simply calculate the E cell of this particular cell reaction. Now next topic is Nast equation, and before discussing Nast equation, we can simply observe that the ore convert into metal and metal convert into ore. This is the natural phenomenon. In the earth crust, we can simply observe in the oxide form of ores, sulfide form of ores, right, nitrides form of ores, and it will be converted into metal after purification process. This shows the concentration based information by Nast in the form of Nast equation. We will discuss this Nast equation in the form of Daniell cell or any particular cell. We can simply observe this value Nast equation in different mode. This is, try to understand what will happen. Ore converted into metal. This process is known as metallurgy process. So ores convert into metal. What concentration will be based for getting better achievement of the metal? So it will discuss in case of Nast equation. So let us begin here. Nast equation. The effect of concentration is not always unity. The electrode reaction Mn plus ion aqueous gaining n electron convert into metal solid. The electrode potential at any concentration measured with respect to standard hydrogen electrode E Mn plus by M equal to E naught Mn plus by M minus RT by NF log concentration of metal by concentration of metal ion. But if the concentration of metal is unity, then what will happen? E metal ion by M equal to E naught metal ion by M minus RT by NF log 1 upon concentration of metal ion, where E is equal to electrode potential under given concentration of the Mn plus ion and temperature T. E naught is equal to standard electrode potential, R is gas constant, T is temperature in K, F is 1 Faraday, N is number of electrons involved in the electrode reaction. If M concentration of metal, R concentration of Zn equal to 1, putting value of R is equal to 8.314 joule per K per mole, F is equal to 96,500 coulomb, and T is equal to 298 K. So what will happen? This formula will be changed in this form. That is E is equal to E naught minus 0.0591 by N log 1 upon Mn plus. So on the basis of the above information, we can discuss what is the Nast equation for Daniell cell or galvanic cell or voltaic cell. Three names are same, and in the semester examination there will be change. There are three names, answer will be same. What will happen in case the cathodic equation of the ECU by Cu ion by Cu, that is copper electrode, E naught copper ion by copper minus RT by 2F, because 2 electron charge. 2 is the number of positive charge which will migrate from one end to another end. 2F log 1 upon copper plus plus and aqueous. For a node, this is the equation for Z ion, zinc ion, and this is the full cell potential for Daniel cell, which are written here. E cell is equal to E cathode minus E anode. E cell is equal to E copper minus E zinc, and put this value in this equation and solve it. This is the next equation for the Daniel cell. What will happen? What they give information about this zinc ion and copper ion concentration? So E cell depends on the concentration of both copper ion and zinc ion. It increases with increase the concentration of copper, and it will decrease with the decrease the concentration of zinc ion. So, and second example we are taken, that is, this is the cell equation, and what will be the next equation for this cell equation? We can simply observe this is the next equation for this cell equation. Generally, in general electrochemical cell, if we take the concentration of A is A, small a is the concentration of capital A, small b is the concentration of capital B. If n electron will be passed from one end to another end, so C convert into C, and D is the small d is the concentration of capital D. So what will be the next equation? This is the general next equation reaction. E cell is equal to E cell naught minus RT by NF log concentration of C ke power C and D ke power D divided by A ke power A and B ke power B. So this is the general equation of next equation, and this is the today's lecture, and you will find out EMF of the cell numerically from different part of the book, any book or online, and we will discuss in next lecture what will be the application of next equation and in their sequence. Thank you very much.